question says using properties of determinants and without expanding in exercises 1 to 7, prove that. We are supposed to prove this is equal to this. Okay. Now this is a big determinant on the left hand side, and what you have on the right hand side is a pretty simple determinant. You have b plus c, c plus a, a plus b, q plus r, r plus p, p plus q, p q r over here, and then you have y z x and x y z over here. Now how do we go about solving this one? Right. Pretty interesting. Let's observe in the LHS. We have a big determinant b plus c, c plus a plus b. That's the first thing. And if you observe in this right hand side, you have a over here, b over here, and a c over here. Okay, there's no a over here. We'll have to bring a over here in the first row somehow. And where can we get a? We get a in this and this columns, right? So let's use that idea. This is q plus r, this is r plus p, this is p plus q, this is y plus z, this is z plus x, and this is x plus y. The idea that I want to use is simple. I will bring this a over here, but I have to get rid of this b and c as well. Okay, subtract this c, subtract this b as well. So the row 1 can be replaced by r1 minus r2 minus r3. This is the transformation that I'll use. This r1 can be replaced by r1 minus r2 minus r3, and with the help of this, what do I get? I get b plus c minus a minus b minus a. So b and c will get cancelled. What will remain is minus a, which is minus 2a. In the LHS, the first term that will remain is minus 2a. Okay, c plus a plus b will remain as it is. What about the second column? What will happen over here? This minus this minus this. Once again, q minus q, r minus r will get cancelled. Minus p will give me minus 2p. And similarly over here, y and z will get cancelled. What you'll get is minus 2x. And yes, do we get a matching apx in the first row? Yes, we get a matching apx in the first row. What else? The second row remains as it is, r plus p, z plus x, and p plus q, x plus y. Okay, what else? Do you observe that you can take a minus 2 common from this row altogether? Yes, I can do that. Let's take a minus 2 common from this row, and this is a, c plus a plus b, this is p, r plus p, q plus p is what I have, p plus q or q plus p. Then you have a x, z plus x, and x plus y over here. Okay. The first target on the right hand side, we have apx, we have obtained that. The next we need bqy over here. Okay, there's no b over here, but there's a bqy over here. We can subtract this r3 and r1. So r3 can be replaced by r3 minus r1 to give me b, q and y. bq and y. What about the CRZ? CRZ is present over here, yes. R2 can also be replaced by R2 minus R1 to give me minus 2 is okay. The first row remains as it is. R3 and R2 are modified on the basis of this. This is A, P, X. What you have is C plus A minus A is C, R plus P minus P is R, Z plus X minus X is Z. A plus B minus A is B, Q plus P minus P is Q, and X plus Y minus X is Y. This is what you have. Right? This is what you have. And after this, what next? What next? If you observe carefully, there's one small step which remains, that is interchange of two rows, this and this. R2 and R3 can be interchanged, and what impact will that have on the value of determinant? The value of determinant becomes negative. So there will be an extra minus introduced by interchanging R2 and R3. This interchange will introduce an extra minus. This minus will become plus 2 times A, P, X, B, Q, Y, C, R, Z. This is what you have. And observe, is this the RHS? Yes, that's the direction in which we wanted to move. We were moving in that direction. This is the RHS, and hence proved. That's the solution of this complete question over here. Is that all? Yes, that's all in this question.